Hey guys, welcome back to Crack Code. Today we're doing another Brainstellar Quant puzzle. This one is called All Girls World. It's an easy problem of probability type. I'll let you guys go over it. Okay, so just to explain the problem once. So imagine a world, or let's just say an island, where let's say there are n families, and the thing is that each family will keep on having a baby until they get one girl. And once they get a girl, they stop over there. Each time they only get one girl, and it's either a girl or a boy, or nothing else. And it's also given that the probability of getting a girl is the same as the probability of getting a boy. And we know that if this is the case, then basically both are equal to 1 by 2. So just at an intuitive level, you might start to think that, okay, now since there's a bias towards a girl child, then the ratio would be more towards a girl than a boy. So it might be that the ratio of a boy to girl would be something like 0.3 or something like that, but basically less than 0.5, right? But actually, this is not the case. So there's two ways to go about solving this problem. The first way I would like to discuss is that we can assume that there are n families and just keep on going through the iterations of having a child. So this is basically what our first method would be. We are going to take n general families and keep on considering what is the average outcome going to be. So this looks something like this. Say we have n families at the beginning, and n by 2 of them get a boy, and n by 2 of them get a girl during the first try. So the families that get a girl will just stop over here, and the families that got a boy on their first turn will have another baby. So again, n by 4 will have a boy, and n by 4 will have a girl. Again, these families stop, and the process continues. This goes to n by 8 and n by 8, a boy and a girl, and you start to get the idea. This process keeps on going. So one thing we notice is that during the first iteration, the number of boys and the number of girls are the same. So the ratio is 1:1. During the second iteration, the number of boys and the number of girls that have been added to the entire set are the exact same. So now the number of boys are basically 3n by 4, and the number of girls is also 3n by 4. I'm talking about the total number of boys and girls on the island right now. Because we had n by 2 girls over here, we had n by 2 boys over here, and now we've added n by 4 more boys and n by 4 more girls. And this process keeps on continuing. We keep on adding the same number of boys and girls every time. So this starts to make us believe that the ratio would in fact be 1:1. Another way to go about solving this is a lot more mathematically sound way of solving this, and I'll show you guys that solution next. So for the second method, basically we now focus on one single family and consider all the different cases that are possible and the probabilities for those cases, and eventually we will find out the expected value of the ratio, right? So just to point out a few examples. So the family could have gotten a girl, right? And that's it. Or it could have gotten a boy and then a girl and then they'd stop. Or they could have gotten 2 boys first and then a girl. Or 3 boys and then a girl. 4 boys and then a girl. And it goes on like this. And there are an infinite number of different possible outcomes that could have happened, right? Because the number of boys that they get before the first girl can keep on going up till infinity. However, the probability of those cases keep on getting smaller and smaller. Since we know that the probability of getting a boy or getting a girl is 1 by 2, basically the probability of this case becomes 1 by 2. For this case, it becomes 1 by 4, as it's basically 1 by 2 into 1 by 2. The first 1 by 2 is for the boy, and the second 1 by 2 is for the girl. For this, it becomes 1 by 2 cubed for each boy and girl. For this case, since there's 3 boys and then a girl, it's basically 1 by 2 times 3 into 1 by 2, which is basically 1 by 2 to the power 4, and it goes on this like this. So what is happening is basically the expected number of boys that a family has is basically 1 by 2, which is the probability. The very first case, this case over here, I'm calling this one the first case, this as the second case, this as the third case. So this is the probability of the first case times the number of boys in the first case. This is the probability of the second case times the number of boys in the second case. The probability of the third case into number of boys that we have in the third case, which is, as you can see, 2 boys, and it goes on like this. And I've done the same calculation for the number of girls, as you can see over here. And now basically we have to solve these two equations. These are two basically infinite summations, and once we have the values x and y, all we have to do is calculate x divided by y. So to calculate x first, so x is basically an arithmetic geometric progression. The way we solve one of these is you do x. So let's first write x. X is 1 by 2, 0, plus 1 by 4 times 1, plus 1 by 8 times 2, plus 1 by 16 times 3, dot, dot, dot. Now x into 1 by 2 gives us 1 by 4, 0, by times 1, by 16, 2, dot. So subtracting this line by this line, we have x by 2, 1 by 4 plus 1 by 8 plus 1 by 16, dot, dot, dot. This is basically a geometric progression with a equal to 1 by 4 and r equal to 1 by 2. So the answer basically becomes 1 upon a upon 1 minus r, which in this case becomes 1 by 2. So this is the value for x. X is 1 by 2. And to calculate y, we know that y is basically this value, which is a simple geometric progression. It is 1 by 2 plus 1 by 4 plus 1 by 8. Again, using the same formula, a upon 1 minus r as the value of the sum, we get y to be sorry, one small mistake. So actually x by 2 is equal to 1 by 2 and y becomes 1, and this implies x is equal to 1. So since x and y are both equal to 1, the ratio, which is basically, since that's what x and y stood for, expected number of boys on expected number of girls, is 1 over 1, which is basically 1:1, or you can say 50%. Thank you.